Hi, my name is Stephen Sindoni, and thank you for tuning in to today's broadcast of Stephen's World Talk Radio. Today's program, I'm excited to have Brad Kallio as my guest. He's a scientist and a solutionist. Brad, thank you for coming on Stephen's World Talk Radio.
Pleasure to be here.
Brad, I'd like to start off this program by asking you who Brad Kallio is and a little bit about yourself. Can you tell the audience and listeners who Brad Kallio is and what your plans are as we go forward here in 2013?
Okay. Yeah, I can do that, I think. Back in early 2000 when Indonesia got hit by the tsunami, being a person that likes to question things, I fix things for a living. I've been a technician most of my life. I started out when I was 14 fixing little tape players and things like that. And I moved into car stereos when I got out of high school and kept evolving from there. Got industrial electronics and robotics work. But when the tsunami hit, I looked at that and it was like any other technician, you look at something and you go, why are we still using square boxes for houses? Especially in putting in environments where you got winds traveling at 150 mile an hour and heavy waves and things like that. There's got to be a better way. And so I sat down one day and I just kind of drew up a house that would be designed to handle those environments, kind of look like an onion, so that, our military today actually builds tanks designed in the same concept, otherwise designed to make things skip off rather than to absorb the energy, so it will be more sustainable to an impact. And I took that thought and designed a home called Enviro House. Didn't go much farther with it, and then of course Hurricane Katrina hit, and I happened to have an injury at that time. Can't keep a good engineer down because I tore the Achilles tendon off my heel. And so I designed a larger scale version of an Enviro House. Designed to survive an impact of a 2x4 at 150 miles an hour, survive 300 mile an hour winds, and the house will float. It's made out of gypsum foam, which is like shaving cream that's made out of plaster of Paris, and it hardens and makes a nice foam surface that doesn't burn, so it would survive really harsh environments, forest fires, things like that. But I needed a material on the outside to coat it, a few other things, and I ran into this guy Paul doing design work at another company for phase converters, and he was interested in magnetic field theory because he was a nuclear physicist working on an AC battery project that he was playing around with, a crystal battery, not a chemical battery. And it was just one of those matches made in the universe. We needed each other, and we were able to help, and we'll go from there. As I was helping him with that, and he helped me with the materials, it occurred to me that there was another underlying problem that we had that superseded even the environmental part of it, so I kind of put that project on the back burner and started looking into where we get our energy source from, realizing that the way we do it today is so backward. I like to put it this way now. We have the technology of the Jetsons, and we have the operating system of the Flintstones. Ugh, man can make fire. We haven't needed to do that for years. But we're locked into this because the operating system is based on fossil fuels. So anyway, I started looking into the way we collect our energy, and I started doing research, and being an electronics and ham radio operator, I had a lot of background in magnetic field theory. And I realized that even the generators that were designed today are backward. They're not designed properly. An airplane blade does not belong on a sailboat for a reason. They don't use them. An airplane blade is designed to throw air, not catch air. So we really need a sail. I don't know why they are using airplane blades. I got a couple ideas about that we can get into later. But it occurred to me we need to make a design for catching energy more efficiently. And I started looking at, okay, Mother Nature doesn't really move very fast, so if you're going to catch wind energy, the only time Mother Nature moves fast is when she's pissed. So you have to catch it at her speed and convert it. And as long as they're using these little generators with 9 little magnets or whatever in them, they have to spin at 1800 RPM. You have to gear that energy up in order to get the generator to transfer energy properly. Because the faster a magnet passes a coil, the more energy you get out of it. So I started looking for generators, the energy conversion device to go from mechanical movement to electrical energy. I couldn't find anything anywhere. I mean, everything was, the slowest I could find was like 1200 RPM. Well, what good is that? By the time you take something moving at 5 RPM, you have to have 10,000 pounds of weight on it. By the time you get it to 500 RPM, you ain't got anything left. Because every time you double your speed, you cut your torque in half. So, well, that was really frustrating. So, after all the research that I did, I finally come to the point where I realized that we have to build our own generators. You can't find them or buy them. Farmers' rules, you build it yourself.
How long were you involved in this process before you came to the epiphany of there was a better way to do this? How long were you involved in the research?
I probably did 4 years of research in the environment house and getting up to that stage, and then the last 4 years I've been just focused strictly on energy.
Great,
and
great.
We've moved pretty fast in that time period.
So the breakthroughs have come in the last 4 years then?
Yes.
So now, Brad, can you tell the listeners in the audience what breakthroughs that you've learned in the last 4 years?
Well, I learned the airplane blade is a multi-billion-dollar lie designed to keep the status quo of the electric companies so that you pay your electric bill. I learned what a kilowatt is. Most people, when they look at their bill, and they say, oh, it's a watt. Well, what is a watt? Most people can't tell you what a watt is. A watt is 0.75 pounds of force, or real close to it. So a kilowatt is 750 pounds of force. For those who want to understand their electric bill out there in the listening audience, take 750 pounds, put it in a backpack, carry it around for an hour. That's what you pay 20 cents for at the electric company for your kilowatt hour of time you use. You're using a certain amount of energy for a certain amount of time to do a certain amount of work. I learned that 1 square foot of surface area in 5-mile-an-hour wind is 2 pounds of force. So to catch a kilowatt, I need a sail of 375 square feet of surface area to catch a kilowatt at 5-mile-an-hour wind. That's why people that are spending $10,000 on these little 6-foot airplane blades that spin around really fast, there's only 6 square feet of surface area there. You know, what good is that? You might be able to charge a cell phone with that, if it even starts moving at all, because it still has to overcome the gearing inside the unit. They're designed to fail to keep the status quo. That's why we're not seeing any real movement in the renewable energy industry, especially with wind and so on. There's a lot of other technologies out there. I've managed to learn 9 different ways of collecting energy from Mother Nature without burning anything.
And those 9 ways are?
Oh, the obvious one, wind, solar, hydraulic are the 3 normal ones people see. Geothermal will be the next one. But there's also kinetic, static, thermodynamic, organic, and magnetic, which is a really big one that has really been kept under wraps. But I think it's all of them. I might be missing one.
No, that was
anyway.
I'm familiar with the magnetics because my friend and inventor Jerry Thomas, another one of your comrades in this new endeavor, is working in that area. So I'm familiar with the magnetics. But you showed me a device yesterday, a generator that works with wind, and what I'd like for you to do is explain that. And I'm going to include a video clip in this interview so people can actually see it, that this is something that does exist and it's here now, and I'm excited to do this interview with you to show you. So tell me about this wind piece of equipment that you created.
Okay. Well, I call it a wind energy converter, which is really what you're doing with wind is you're catching it in some way, shape, or form, or energy collector and a wind energy converter. I call them ECDs. The wind energy collector is basically a sail that I've made into valves, so that I call it a design sail valve, convenient enough. And what happens is it opens into the standard cup, like you see some people use barrels and things on an arm and a blade, or the little cups you see for windicators, for speed. You see them in weather stations. Well, this is the same basic design, but on steroids. It's the idea is, since I can get 1 square foot of surface area and 5-mile-an-hour wind is 2 pounds of force, I have 60 square feet of sail. Each blade opens up into a cup on the downwind side, but on the upwind side it collapses and becomes a small kite tail. So I have 8 small kite tails on this sail valve system. That's sitting out on a 10-foot arm, which gives me my pry power, which gives me more torque to work with. And in 5-mile-an-hour wind, a blade of that size will deliver 1,500 pounds of torque to the drive shaft. That's 2,000 watts of energy. A home can pretty much run just about everything in it in 2,000 watts of energy.
So based on what you've created, conventional electricity to heat homes or to electrify homes to give heat and sources of energy can now be done away with using your wind.
This design will work. There are other ones that will probably work better out there. I challenge people out there, build a better mousetrap. I'm showing you how to do it. If you think you can do it better, please do.
Well, you know what? Speaking of showing people, we're going to show this video of your invention. But for people who want to learn more about what you're doing, how can they see more? Do you have a website?
Yeah, it's Zynoc.com, Z-Y-N-O-C. And it's the Zynoc Foundation. And the foundation's goal is to basically teach people how to build their own systems so that they can go out and teach others. So when I bring them in, you're not buying a system when you come to school with our program. You get a working operational system that will fit in your environment. Because when you're collecting energy from Mother Nature, you have to make sure you don't interfere with Mother Nature too much in a way. So the blade design has a natural drag in it so that its cut-in speed is 0.5 mile-an-hour wind, but its maximum speed is about 70 RPM, even in 90-mile-an-hour wind. It won't stop spinning, it just won't overspin. Okay. The other half of the device, of course, which makes all of the sail valve part of it work, is the energy conversion device. Since a small motor with small magnets, you're not going to get, you have that speed problem. So what I did is I went to a 6-foot wheel with a lot of little magnets, and now I've got an ability to have low speed where I've got a fast movement on the outside of the wheel, creating the energy that I need transferred efficiently. So when I'm all put together with the generator or energy conversion device at the bottom and the energy collection device at the top, it's connected with the drive shaft in between. When it's all assembled, I have one moving part. KISS, keep it simple.
Well, that you have. You have definitely kept it simple. You've got my attention. As I said, I was fortunate enough to be invited to one of your presentations yesterday. As a result of it, here we are today. I felt it was important to share this with my YouTube viewers and people all over the world who want a new source of energy. Are there any other ways that we can get a hold of you, see what else you're doing? I know you have your website, the Zynoc.com. Are you on YouTube? Are you on Facebook?
Yes.
Can you tell us?
Yeah. Brad Kallio on Facebook. Zynoc, search YouTube. Or YouTube, search Zynoc. Energy, 6-foot, ECD. Any of those words on the end will bring you right there. I have a video of some of the earlier experiments, like the wind blade design originally when I had it mounted to the van. Made my van look like a big wind-up toy. I have the generators on there showing, various applications.
So
there's an interview with PBS and Grand Valley State University that's on there. There's a few other ones. What's the name of it? Exported from Michigan is documentary that's coming out in April. That should be pretty interesting.
Well, great. I'm excited.
Zynoc.com, yeah.
I'm excited to have you on today and to let the viewers and listeners know that the future is here now. We just have to embrace it. And again, Brad, I want to thank you for coming on Stevens World Talk Radio. And I hope to do many more of these interviews with you. Thank you for coming on today.
You're welcome.
You ready, guys? Go ahead and give her a whirl. 147 ohm resistor. Holy moly. Okay, I think we made it. That's 312 volts.